Hi guys, we're going to do a titration today, but we're going to do the titration with a pH meter so you can see how the titration curve and the graph, when graphed against pH, compares to the equivalence point. So you can kind of see where all the important points of a titration are on the titration graph. So we're going to do the titration today using vinegar, which is acetic acid, and sodium hydroxide. Okay. So, the first thing we need, since we are exploring the the concentration of vinegar, we're going to try to calculate the concentration of acetic acid in this vinegar. So the first thing we need is the volume of our vinegar. I want about 25 milliliters. All right, so my initial amount is going to be 25.2 milliliters of vinegar. 25.2 milliliters of vinegar. I'll put that in my beaker and get my magnet stirring. Okay, the next thing I want to do is I want to get my pH probe in there. So I'm going to take the pH probe out of the buffer here. Nope. The other thing I want to do is I want to rinse that buffer off of my pH probe. Okay, so I rinsed the pH probe with the vinegar, and now I can get my initial reading. So the pH with 0 base added is 2.5. All right, now let's set up our sodium hydroxide. Make sure that's closed. And the first thing I want to do is rinse my burette with sodium hydroxide. I'll pour it through my burette, pour it into my dump. And now I can fill it for real. So this is 3 molar sodium hydroxide that we are using. Since we know the concentration of our base, that means the base is the titrant and the vinegar is the analyte. Now I'm also going to add some phenolphthalein so you can see where the equivalence point, or the end point at least, happens on our graph. All right, now burettes are notoriously difficult to read, so I want to take a look at the burette itself so you can see the initial measurement. Okay, so there you go. Notice that it is labeled from the top down. So that top line is the 0, and then it is 1. So that initial reading is not 1.6-ish. That initial reading has to be taken from the top down. So it's probably around 0.4-ish. Again, be careful reading a burette. They are notoriously difficult to read. So let me set you down and I'll take a couple of readings for you. All right, initially, it is going to be 0.45 milliliters. So our initial reading of the base in the burette is 0.45 milliliters. Okay, now I'm going to add the base in half a milliliter at a time. So this is not going to be a true titration. We are not going to go drop by drop by drop until we hit the end point. I'm going to add about a half a milliliter at a time, and then we'll graph the volume we added against the pH so you can see what that curve looks like. And then you will be able to see approximately where the end point falls in here. Again, because we're not going to do this as like a true titration, we won't get a perfect calculation out of here, but we can do a ballpark calculation. And then, like I said, the point I really want you to get out of this is what the graph looks like so that we can talk about what kind of molecules are at each point in the graph. Okay, here we go. So, initial volume of base, we have added 0 amount of base, and our initial reading is 0.45 milliliters. Our pH is at 2.50. All right, next reading of base, next reading off our burette is 0.90 milliliters. pH is at 3.42. Next reading off our burette is 1.41 milliliters. pH is at 3.77. Next reading off our burette is 1.90. pH is 4.00. Burette reads at 2.45. pH is 4.18. Burette reads at 2.85. pH is 4.31. Burette reads at 3.49. pH is 4.48. Burette reads at 3.90. pH is 4.58. Burette reads at 4.45. pH is 4.69. Burette reads at 5.01. pH is 4.82. Burette is at 5.50. pH 4.93. Burette reads at 6.00. pH is at 5.06. Burette is at 6.41. pH is 5.17. Burette is at 7.05. pH 5.53. Burette is at 7.41. pH is 5.50. Burette is at 7.95. pH is 5.78. Burette is at 8.45. pH 6.23. All right, Burette is at 8.95. pH 11. Oh, it's still going up. Give us some time. Notice the color change. Ooh. It was pretty dramatic, right? Just less than half a milliliter of base, and it went from clear to like bright pink. All right, we're gonna call that pH at 11.32. Let's keep going a little bit and see what happens. Okay, Burette reads at 9.50, pH 12.61. Burette is at 9.90, pH is 12.94. Burette is at 10.40. No, 10.50. pH is 13.2. Burette is at 10.95. pH is 13.30. Burette reads 11.48. pH 13.38. Burette is at 11.95. pH is 13.44. Burette is at 12.50. pH is 13.49. Burette reads at 12.95. pH is at 13.52. Okay, so that's enough points to give us a pretty good graph. Go ahead and graph that by volume of base added by pH. Now you want to think about a couple things. First of all, which one was our independent variable? Which one was the variable that we changed? And hopefully you said volume of the base. Yes, we changed the volume of the base. So volume of base added will be our x-axis. Now as we changed the volume of the base, what changed in response? pH. So pH will be your y-axis. Now the second point is, please note that the Burette reading is not the volume of the base added. So I'm going to let you think about that a little bit. How do we get the volume that we added of the base from that Burette reading? And we can talk about that more together. Now, before you go, we're going to talk about disposal. So first of all, we're going to take this pH meter out, and we're going to rinse it again in vinegar, just so we have something that's fairly weak and not something that's fairly small on here, because the next place our pH meter is going to go is back into its buffer. We'd rather have something weak mixed with its buffer and not something strong. Also, when you store a buffer, when you store a pH probe, how do you want to store it? And hopefully you said upright, so you need to make sure you put it in the box the right way so that it's going to be stored standing up. And I'll disconnect that and store that later. Okay, next we want to let this drain out of our burette. So this is the excess sodium hydroxide. We're going to let it drain out of our burette. Now we don't want to pour excess sodium hydroxide down the drain. It's too strong to go into our city's wastewater treatment plant. So what we want to do first is we want to neutralize that. Now lucky for us, we have a color change that indicates about the point of neutralization. Also think of this to yourself. Would you rather have sodium hydroxide go down the drain or vinegar? And hopefully you said vinegar. We'd rather have a weak acid go down the drain than a strong base. And so after this ends up draining, what we can do is we can just add vinegar until it clears again. And once it's clear, we can put that down the drain. Rinse everything really well. Make sure you rinse out the burette as well. You want to store the burette upside down so excess stuff comes out and doesn't store in here. We don't want any solids to form in here because they'll form crystals and then they'll actually clog our burette. So make sure you store your burette upside down after you have rinsed it. Okay, hopefully you got all that data. We will talk about it together.